Hello, so in this session we'll talk about quadratic function. So vertex form of quadratic function is fx equals to a times x minus h squared plus k, where h and k is the coordinate of the vertex. Okay, for example, this one, we have plus 3 and minus 3. So be careful when we have h is x subtract h, but this is plus. So that means we need to rewrite the function as negative x minus negative 3 squared minus 3, because minus negative 3 equivalent to plus 3. And we write it as a x minus a x coordinate form, which is our h. So that means our vertex is negative 3 and the negative 3. It's in here. Since a, so there's two types of quadratic function, two types of graph. Either the parabola opens up like a U, or the parabola opens down like an N. So if it's open up, a is going to be greater than 0, which is a positive number. If a is less than 0, a negative number, then it's going to be open down. So now let's look at number 1. Number 1 is negative. So that means the graph is going to be open down. So the graph is going to look like that. Okay, second one. Fx equals to x minus 3 squared plus 4. So we have what? Remember, the vertex form is in the form of what? A times x minus h squared plus k. So now we have our h equals to 3 and k equals to 4. So vertex coordinate should be 3 and 4. And a equals to what? A equals to 1. Here doesn't have a, but that means times 1. So a equals to 1 is a positive number, so that means the graph is going to be open up. 3, 4 opens up. Okay, next one here. So we have a equals to negative 2, which is a less than 0. So it's a negative number. So we know that the graph is going to be open down. And what will be the vertex? Vertex is going to be x minus h squared plus k. So that means our h equals to 4, k equals to negative 2. So 4 and negative 2 open down. Okay, this one. Again, a equals to 1/4. So that means it's greater than 0, a positive number. Even though it's a fraction, still a positive number, it's going to be open up. Vertex equals to what? Again, this is the tricky part. Plus 4, we want to rewrite it as what? 1/4 x minus negative 4 squared plus 3. So the vertex should be negative 4 and the positive 3. Open up, negative 4, positive 3 here. Open up. Okay, so standard form. Standard form, we have fx equals to ax squared plus bs plus c. Okay, so for standard form, we can find a couple of things. First, if the graph is open up or open down, that's determined by a. If a is greater than 0, it's going to be open up. If a is less than 0, it's open down. Second, we need to find our intercepts. For intercept, we have 2. Y-intercept. What is Y-intercept? You think about it. So is the graph intercept with y-axis. That means on this point, x equals to 0. The x coordinate 0. So we let x equals to 0. So therefore f of 0 equals to c. So that means our y-intercept is 0 and c. So now x-intercept. So look at the graph again. X-intercept is when the graph intersects with x-axis, right? So that means on x-axis, the y-coordinate equals to 0. When y equals to 0, that means you want to set the function equals to 0 and then solve for x. So you need to use quadratic formula. So the last one is how do you find vertex? So they have a formula. Vertex the x-coordinate equals to negative b over 2a. And then after you find the x-coordinate, you can find the y-coordinate by substituting the x-coordinate into it. So that would be your vertex. Okay, so now let's take a look at the example. Number 5, let's find. So a is equals to negative 1. So that means the graph is going to be up and down. Okay, so y-intercept is when x equals to 0. So we have 0 and negative 5. Okay, x-intercept. X-intercept is the whole function equals to 0. I have negative x squared minus 4x minus 5 equals to 0. How can we solve it? So the way to solve it is by using quadratic formula, which is x equals to negative b plus or minus 4 of b squared b squared minus 4ac square root over 2a. So our b equals to negative 4, so negative b should equal to positive 4, plus or minus b squared, which is 16, minus 4 times a, negative 1, c is negative 5, over 2 times negative 1. So this is equals to 4 plus or minus negative 4 over 2. So now look at whatever inside the square root, the radical. So there's a negative number here. We know that if there's a negative number, that means there's no real number solution. I mean, of course, you can write it as square root of 4 times I, the imaginary number. But when we talked about we drawing a graph on a coordinate, we only discussed the real number. So that means there's no real number solution. So that means what? There's no solution for x. That means there's no x-intercept, which is fine. Okay, now is the vertex. So vertex, we use the formula. The x-coordinate is negative b over 2a, b equals to negative 4, a equals to negative 1. So the x-coordinate of the vertex equals to negative 4. We still need to find the y-coordinate. So in the function, if you already have the x-coordinate, you can plug in x equals to negative 4 to find the y-coordinate. So f of negative 4 equals to negative 16 plus 16 minus 5, which is negative 5. So vertex is equal to, that makes no sense. I must do something wrong. Negative 4, oh, this is divided by 2, sorry. This one, I know I did something wrong. Here, this is divided by 2, so that means our x-coordinate should be negative 2. So here, we should plug in f of negative 2 to find the y-coordinate of the vertex, which is negative 4 plus 8 minus 5, which is negative 1. So the vertex equals to negative 2, negative 1. Okay, so let's find all the points here. We have a negative 2 and negative 1. No x-coordinate, no x-intercept, but there's a y-intercept and open down. Here you are. So that makes sense. You don't have X. If it's open up, you will have an X-intercept. But since this is open down, yes, there's no X-intercept because the graph is going down. Okay, so now let's do number 6. Okay, again, let me use different color of pen. It's a little bit messy, but it's okay. Okay, so A equals to 1, right? So it's greater than 0, it's a positive number. We know the graph is going to be open up. And Y-intercept equals to when X equals to 0, so we have 0 and 12. X-intercept is when Y equals to 0. That means we want to set the function equals to 0. Okay, so how do we solve that? We use factor. Of course, you can use quadratic formula, whatever way that makes you more comfortable. So for me, this is easier by just factor it. So I have a 2x-intercept, -6, and x equals to -2. And then vertex. Vertex is what? We use the formula x equals to b over 2a. So b equals to 8, a equals to 1. So that means our vertex is equal to -4. And then f of -4 equals to 16 minus 32 plus 12, which is 28, -4. So vertex should be when x equals to -4, y equals to -4. Okay, vertex is -4, -4. X-intercept is -6 and -2. Y-intercept is on top, is outside of this graph, which is fine. That means we don't do the y-intercept in here. So here's the graph. Okay, let's do number 8. I mean, maybe you can pause the video and try to do it by yourself. I'm going to go over all of the examples here. Okay, so now let's take a look. For this one is the standard form. First of all, we need to find out where's A. A is equal to 1/2. That means positive number, open up. And then we have y-intercept. When x equals to 0, y equals to 9. And now we need to find x-intercept. X-intercept is when the function equals to 0. And we try to solve it. Okay, let's try to do it, see if we can do it without quadratic formula. So we need to times 2 on both sides so that we can get rid of the 1/2. It would be easier if we get rid of the 1/2. So let's times 2 on both sides. We have 0 times 2 is 0. Okay, so let's see if we can factor this one. 18. 2 times 9, no. 3 and so let's see, 18, there's not that many combinations since they have to be negative, so that means these two have to be negative. -2 and -9, no, it doesn't work. -3, -6, it won't work. Anything else? No, so maybe we can use the factor this time. So if that's the case, let's use quadratic formula. We have x equals to -b plus or minus b squared minus 4ac over 2a. This is equal to negative a plus or minus -a squared minus 4 times 1 times 18 over 2 times 1. So I have 8 plus or minus 64 minus 32 over 2. So I have 8 positive or negative 13.2 over 2. And then 13.2 we can simplify as what? 4 times 8. So I have, or maybe 16 times 2. Yeah, 16 times 2. So I have to factor the 4 out over 2. Now we can cross cancel because they all both have the factor of 2. So when you cross cancel, you have 4 and 2 left, and this is 1. So you have 4 plus or minus 2 square root of 2. Okay, so that's your x-intercept. So where is it? So you can use a calculator to figure out what is that number is. Okay, after we find A, Y-intercept, X-intercept, we still need to find the vertex. So vertex is equals to negative B, X equals to negative B over 2A, B equals to negative 4, 2 times A is 1/2. So that means our vertex, the x-coordinate equals to 4. So f of 4 equals to 1/2 times 4 squared, which is 8, minus 16 plus 9. This is equals to 1. So vertex is 4 and 1. So 4 and 1 here. Okay, I did something wrong, but I'll show you what I did wrong. So y-intercept is on top of here, we can see it, and it's open up. So the graph should look like this. So that means you're not supposed to have x-intercept. But somehow, I still somehow say, hey, there's an x-intercept 4 plus or minus 2 square root of 2. That means I did something wrong. But I shouldn't do the vertex form and the y-intercept wrong. Maybe you already caught my mistake. Good job if you did. Here, 4 times 1 times 18. This is not equal to 13.2 because I thought this is 8. So 4 times 18 should equals to 17.2. So that means whatever inside here is a negative number, negative 8. So that means you can simplify it. If this is a negative number, that means there's no x-intercept, which is match our graph. There's no x-intercept when it opens up. Okay, let's do another one. Let me do another one. Try to do it by yourself, because maybe you did a better job than I do. Okay, I'm going to use a purple one. Okay, so I need to find A equals to negative 2, open up, no, open down, because it's a negative number. And then we find y-intercept, 0 and negative 6, x-intercept. So x-intercept is negative 2x squared plus a dash minus 6 equals to 0. Let's see if we can factor it. So let's divide it by negative 2 on both sides. I have x squared minus 4x plus 3 equals to 0. Oh yeah, we can factor this one. This is equal to x minus 3 times x minus 1 equals to 0. So that means our x-intercept is x equals to 3, and when x equals to 1. So 3 and 1. Y-intercept is negative 6, opens down, and we still need to find the vertex. Vertex is x equals to negative b over 2a. So b equals to 8, 2 times negative 2, which gives you a positive number, 4. So f of 4 equals to negative 2 times 16 squared. 4 squared, not 16 squared. So negative 2 times 16 equals to 36 plus 13.2. No, 16 times 2. Yeah, 13.2. I'm sorry. I write it right, but I don't know why I did it wrong. This is negative 6. So the vertex should be 4 and then negative 6. This is not right because vertex is supposed to be in between the intercept because the whole graph should be symmetric. So that means I did something wrong. That means your vertex should be on the line of the symmetric line. Should be on 2. So let's look at here the x-coordinate. I did this wrong. Should be negative 8 divided by negative 4. So that means this is 2. So I'm trying to find f of 2 equals to negative 2 times 4 plus 16 minus 8 minus 6 minus 6. So I have negative 8 plus 16 minus 6, which is 2. So I should have the vertex when x equals to 2, y equals to 2. open down. Okay, so this is the graph. Okay, factor form. So the factor form of a quadratic function should be f(x) equals to a times x minus m, our first factor, and our second factor, where will help us to really quickly to identify where is the x-intercept. So the x-intercept should be m1, 0, and then m2, 0. Okay, why is that? Because look, what is x-intercept? X-intercept is when the function equals to 0. Let's look at our example. So when we set the function equals to 0, what do we have? We have x equals to 3 or x equals to -1. S equals to 3, s equals to -1. That means this is our 2x-intercept. Now we need to find our y-intercept. Y-intercept is when x equals to 0. So we substitute 0 into the function. We have 0 minus 3, and then 0 plus 1. So it gives you -3. So y-intercept is 0 and -3. 0 and -3. And look at the function. Since a is greater than 0, so we know that it's open up. And now we still need to find the vertex. So well, there's two ways you can find the vertex. Either you can FOIL it first. Okay? When you FOIL the function, you will get a standard form of a quadratic function, which is in here. And then you just find the vertex, like what we did earlier. Use the formula x equals to -b over 2a, and then substitute into the function. But there's an easier way to do it is, the vertex is, okay, parabola is a symmetric over the vertex line, right? So that means, look, if you have x-intercept at -1 and 3, -1 and 3, so that means the vertex has to be in between, which is in here, right? That means x is going to equals to 1. So when x equals to 1, let's find the y coordinate. So when x equals to 1, I have a 1 minus 3 times 1 plus 1. So I have -2 times 2, which is 4. So the vertex should be 1, -4 in here. So when you connect these dots together, you will find your parabola. Okay, let's do another examples. So here, a equals to -2. So we know that it's going to be open down the parabola. And then the x-intercept, easy to find, which is 1 and 4. Because you want to set the equation equals to 0, and then you will find out, hey, the first x-intercept is when x equals to 1. The second one is when x equals to 4. 1 and 4. Okay, y-intercept. Y-intercept is when x equals to 0. So I have f of 0 equals to -2. Don't forget the -2. So 0 minus 1, -1. 0 minus 4, -4. I have -8. So that means here's my y-intercept. Now we still need to find the vertex. Remember, vertex is in between. You can either FOIL it and try to use the formula, which is x equals to -b over 2a. Or you just find the symmetric line, where is 2.5, right? In between 1 and 4 should be 2.5. So we know that x coordinate equals to 2.5, positive 2.5. So f of 2.5 equals to -2 times 2.5 minus 1 is 1.5. And then 2.5 minus 4 is -1.5. So I have a positive 2 times 2.25, which is 4.5. So I have a 2.5 and 4.5, which is here. This is our vertex here. So that would be a graph. Okay, let's do another one. Okay, so this one is a little bit special. How do you find another x-intercept? So now when you look at this one, you can think about the x as x minus 0 or plus 0, because that means it's x. So that means your x-intercept is x equals to 0 or x equals to -6. So it's 0, -6. Y-intercept is when x equals to 0, which is 1/2, 0, and then 0 plus 6, which is 0, which is the same one in here. So sometimes x and y-intercept, they could be the same thing. Okay, so now the next one is we want to find the vertex. So vertex is in between. So -6 to 0, the between one should be what? -3. So x equals to -3. So when x equals to -3, the function equals to 1/2 times -3 times -3 plus 6, which is 9/2, which is -4.5, which is here. Okay, and now let's take a look. A equals to 1/2, which is open up. We know that the graph is going to look like a U. Okay, next one. Try to do it by yourself. Pause the video. So we have x-intercept equals to 2, 0 or -2, 0. Y-intercept is f of 0 equals to -4 times -2 times +2, which is 16. Ooh, that's really far off. So 2 and -2. Okay, vertex. So between -2 and 2, we know that, hey, the vertex is on what? Y-axis. So x equals to 0. That means, hey, the y-axis happens to be the vertex. If you don't believe me, try to do it by yourself. Because f of 0, we just calculate that, is equal to 16, which is happen to be y-axis. So that means the graph is going to look like this one. Okay, last part. Last two parts. Converting the standard form to the vertex form. In this one, we need to use how to complete the functions. So remember, we learned it from last section or last module. If we have x squared plus bx, how can you turn this into a what? A complete square. So we need to add, if equals to some number, like say c, x squared plus bs equals to c, what would you do? You need to add half b squared on both sides. So on this side, on the left side, you will get what? S plus b squared. And then on the right is whatever that on the right is. Okay, so we use the same argument in here. So in order to make the function equal, how do you do it? There's two ways. Either you add the same number on both sides at the same time. That makes sense. Such as 4 equals to 4. In order to make the function equal, you can't just add 1 on the left side and then you don't add 1 on the other side, because then the function will become 5. It's not equal to 4. In order to make it equal, you need to add it on both sides. Or there's another trick. It's 4 equals to 4, right? You add 1 on one side. The other way to make it even is you subtract it at the same time. So you add the same number and subtract the same number. The function still equals to 4. So that means this is still equal. Okay, so now let's take a look at number 13. How do we complete the function? when we complete it, let's take a look. Our quadratic term with a coefficient equals to 1. But now this one is equal to -2. What you can do is you factor the -2 out. So I have -2 x squared plus, factor 2 out, this has become minus 2x minus 7. So now let's look at the parentheses. In order to complete the square, we need to add b over 2 squared. So I have 2 times x squared minus 2s, add b over 2 squared, and then minus b over 2 squared, minus 7. So why we need to add something and subtract something? Remember the example in here. If you want 4 equals to 4, you add 1 on one side. In order to make even, you can either add 1 to the other side, or after you add 1, you subtract the 1 right away. So that's why when we add b over 2 squared, and then we subtract the same thing. So the first 3 terms, this is going to turn into what? A quadratic, complete the square, the perfect square, which is x minus, this is 2, b is equals to 2. 1, b is equals to -2, sorry. Square. Okay, and then we write everything the same. This is just from the first 3 terms become this part. Okay, everything should be the same. And then this is minus 1, minus 7. Now you need to simplify, because what? The vertex form is not like x minus h squared times a plus k. But this doesn't look like it. We still need to simplify this. We distribute the 2 inside. We have x minus 1 squared minus 2 minus 7. So I have 2 times x minus 1 squared minus 9. So our h is equals to 1 and k equals to -9. Okay, do another one. Again, your first step is you try to factor the coefficient out. Factor the 6 out. We have 6 times x squared minus 10x plus 156. And then we want to complete the square by adding b half squared. But we need to also subtract b half squared plus 156. Okay, simplify it. First 3 terms will become what? The perfect square. X minus 5 squared. And then this is 5 squared, which is minus 25 plus 156. And then you simplify it. You have 6x minus 5 squared minus 150 at 156. So you have 6 times x minus 5 squared plus 6. Okay, we have 2 more exercises. I'm going to finish it. This one, factor the 5 out. That would be your first step. So 5 times x squared plus 10x plus 115. And then what do you need to add? You add half b squared, which is 10 over 2 squared minus 10 over 2 squared plus 115.5. And then the first 3 terms, we turn into what? S plus our half b, which is 5 squared minus 25 plus 115.5. So 5 times x plus 5 squared minus 75 plus 115. So the function become plus 14. Okay, again, if you don't remember how to complete the square, from this step to here, please go over the previous material that we've done before, last module, which is module 3. Okay, last one, fraction. I know that we don't like fraction, but it's not as hard as you think. So first step is you want to factor 1/3. So when you factor 1/3, this is equals to negative 1/3. Actually, it's x squared plus what? Plus, because you factor in the negative sign, you have a 20x. Actually, this time I'm going to keep the 100 inside because, again, I don't want to see the fractions. So here, everything is pretty. We will not have the fractions. So I have a negative 1/3 x squared plus 20x plus, actually this one, they can just form a perfect square. If you can see it right away, just use the old way. You plus 20 half square and minus 20 half square. And then don't forget the 100. Okay. So the first three parts, you have what? X plus 10 square. And then look, 10 square is equal to 100. 100 minus 100 plus 100, which is 0. So which means this one is 0. So I have 1/3 of x plus 10 square. Okay, last part, the application of a quadratic function. So a rock is thrown upwards from the top 112-foot high cliff overlook the ocean at the speed of 92 feet per second. The rock's height above the ocean can be modeled by the equation. Blah, 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 blah. So basically, you throw a rock. You're standing on the cliff and you throw a rock towards the ocean. So what does it look like? So that means this is I don't know how to draw. So this is the cliff. You were standing here. And this is the ocean. So in order to make it look like ocean, I'm going to draw a fish. Oh. Okay, so you throw a rock. What does your rock look like when you're throwing it? So the rock is on your hand, right? When you throw it, the first thing you do is what? It goes up, the rock goes up because the gravity is going to go down again. So this is the trajectory of the rock is going to look like. So when does the rock reach maximum height? So the maximum height is here, right? That would be what, aka vertex. So basically it's asking you the x-coordinate of the vertex because the x-coordinate related to the time. So when does the rock reach the vertex? So we use the vertex formula, which is negative b over 2a, which is negative b 96 over 2 times negative 16. Equals to 3. So that means at 3 seconds, after you throw the rock 3 seconds, it's going to reach the maximum height. Okay, now they ask you what's the maximum height. So that means the maximum height means, again, it's related to the vertex. When you see maximum or minimum, it has something to do with the vertex. So that means I substitute the vertex in it, substitute the time. I have negative 16 times 3 squared plus 96 times 3 plus 112. So the maximum height is 256. Okay. And then when does the rock hit the ocean? When it hit the ocean means what? The rock gets to this point. So look, this is the coordinate, right? When you hit the ocean, that means when y equals to 0, when the height equals to 0. So that means you will set the equation x squared plus 19.6x plus 112 equals to 0. And then solve for t. You will get 2t, one is positive and the one is negative. Since t is the term, you have to drop the negative answer. Okay, let's do another example. The last example we have. So a ball is thrown upwards from the top of a 14-foot high building at a speed of 18 feet per second. The ball's height above the ground can be modeled by the equation. Again, if you throw in, there's a building, and then you were standing on top of the building. You throw a ball, the ball's going up and then go down, right? This is the trajectory. And we let this become our coordinate. This is what? Parabola. I mean, you can tell this is parabola because the function they give you, the model they give you is a quadratic function. So when does the ball reach the maximum? Maximum is what? Find the vertex. So I have x equals to negative b over 2a, which is negative 80 over 2 times negative 16, which is negative 2, positive 2/2. That means after 2.5 seconds, the ball is going to reach its maximum. Or you can keep it 5/2. Either way, 5/2 maybe it's easier to calculate when it comes to maximum height. So again, maximum height, that means you want to substitute. As long as you draw the graph, this is really clear. This is where you are throwing the ball, which means when the time equals to 0, right? That means they want you to find the x, the y-intercept. But they already give you, which is 14 feet above. But also from the equation, you can also tell, hey, this is the y-intercept, which is 40. That is your initial, where the ball stands, where you're holding the ball. Or when you hit the ground, that means what? When the ball hit the ground, that means the height equals to 0. So as long as you understand that concept, that will be the application of the quadratic function. So now let's continue. When the time equals to 5/2 seconds, the ball reaches its maximum. Okay, let's calculate it. It's easier than you think. 5 times, okay, this is 40, so I have a 200 plus 40. Okay, negative 16 divided by 4, we have a negative 4 left. So I have a negative 4 times 5, which is negative 20, times 5, negative 100, plus 200 plus 40, which is 140. So the maximum height is 140, whatever that unit is, feet. Okay, when does the ball hit the ground? When the ball hit the ground, remember, is when the height equals to 0. So let's do this. I have negative 16 squared plus 80t plus 40 equals to 0. Let's solve it. Like divided by negative 16 on both sides, I have a t plus 5t equals to a plus. Should be subtract. Subtract 16. They can divide it. So I have divided by 4. I have a divided by 8. I have a 5/2 equals to 0. And then apparently this one we can factor, and then you use the quadratic formula. Again, you will get 2 answers. You only want to keep the positive one because when it comes to time, you don't have a negative time. Okay, it's a little bit long, but that's it for today's class. Let me know if you have other questions.